So in example 3 is when we start combining both of them. Okay, again, it's in function notation. The original graph is given as just f of x, just some random graph. And now we look at the graph we want to sketch. There's a 4 on the outside. So that 4 on the outside, that is going to multiply your y values by 4. It's going to be a vertical stretch. And the negative 0.5 is on the inside. That's going to multiply your x values by negative 2. So as soon as you start to do more than one thing, then it makes sense to look at what happens to specific points. The most important point on here is this one, the starting point, negative 2, 0. But if we look and we can see, oh, we have another point here at negative 1, 1. And maybe over here you see that you have another point at 2, 2. And so if we draw these arrows to show those points are changing, and above this arrow we say, I know that I'm going to multiply my y by 4 and my x by negative 2, well, what's going to happen to those points? Okay, x by negative 2 will give me positive 4, positive 2, negative 4. The y by 4 will keep it at 0. This one will be at 4, and this one would be at 8. So when I go to sketch this graph, I know that I'm going to have 4, 0, 2, 4, and negative 4, 8 is even off my charts, but I'll just put a dot way up there just for fun. Now, those 3 dots are going to form the graph, but we still need to make sure that we're following the ideas of what's happening. So the y by 4, that's stretching things vertically. So you imagine pulling away from the x-axis. The x by negative 2, well, the negative is going to be a horizontal reflection and a horizontal stretch. So I'm using just abbreviations there. But we're going to flip it over the y-axis and stretch it away. This is a key point on the original graph, right? Because that's where that graph starts. So if we think that's this point, it changes to this point. So when I start to graph, I'm like, okay, I have to start here. I need to go through these other points. That helps me see where I start, and I know what the shape is supposed to look like. Again, now that I've drawn it, does it look like I've had a horizontal reflection over the y-axis? Yes. The stretches are a little bit hard to tell if they've done exactly what they needed to, because you stretch it vertically, but then you stretch it horizontally. But it appears to be right. Okay? State the domain and range of each function. So our original domain was x is bigger than or equal to negative 2. Our original range was y is bigger than or equal to 0. On our blue graph, our new domain is x is less than or equal to 4. And our new range is, well, new range is still the same. Y is bigger than or equal to 0. Yeah. The 0 would be included, the negative 2 would be included. So interval notation, for example, for the first one would be like this. Negative 2 to infinity. Interval notation for this one would be negative infinity to 4. Now I'm going to add a part B to this question. Part B. Did you recognize the shape of the first graph from our activity right at the beginning, right? It's one of the four. It's the square root graph, okay? So it's the square root graph, but it's the square root graph moved 2 to the left. So the original one in red, which would be the y equals f of x, if I wanted to write an explicit equation, and a reminder, wow, I spelled explicity. We'll take that y off. There. A reminder that explicit equation is an equation just with the x's. And so if it's a square root graph moved 2 to the left, that would show up inside your function, and it would be x plus 2. Now, what did we do to that x plus 2 graph? We stretched it, flipped it, reflected it, and so to find the explicit equation for the blue graph, we're really going to have to use our knowledge of functions. So for our blue graph, this is what it says. And we now know that f of x is the square root of x plus 2. Okay, so for our blue graph, well, there would still be a 4 out in front. And then instead of f of x, we need to write f of negative 0.5x. So remember, what does a function do? A function does, wherever the x is, whatever you put in, you replace the x. So I had square root of x plus 2. Now instead of the x, I'll have negative 0.5x and then plus 2. So if we close the bracket here, and this could just be written as 4 square root of negative 0.5x plus 2 in the end. So questions for this one are 7, 9, and 10. No, we just did this one example.